All right, so we're on page 391. Number 5. And I thought I did this one with y'all.
This one wasn't on Slater.
No, I think you did it.
Wow, Palmer.
Palmer, why would you say something like that?
All right, number of digits in a random integer from 0 through 999. So, how many digits could I possibly have? I could have anywhere from what? 1 to 3, right? How many integers? How many places? Yeah. So 25 would have 2 places. 121 would have 3 places. 5 would have 1 place. So how many numbers from 0 to 99 have 1? Close. 10, because look, they're including 0, right? How about how many have 2 places?
90.
All right, so if we start at 10, we have 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. And then... All right, it's got to add up to what? Look what it's got to add up to. Actually, it's got to add to 1,000 because you're including 0, right? So 100. No, 90. 90. 90. Right? Because you're including. Are you hot? I'm sorry. How about 3? It's because you're including 0 here is why it's a little bit confusing. 900. So this would all add up to the 1,000 that I need, right? So now if I did a probability table, my random, this is not going to work. N is my random variable, so this is my probability of N. So I could have 1, I could have 2, or I could have 3 placeholders. So this is 10 out of 1,000, right? Y'all are still saying 900. 90 out of 1,000, and this is 900 out of 1,000. Right? Does that make sense? Yeah, and the reason you have to is because it says from 0 to. All right, what else on your homework? All right, let's look at it by, so. Okay, I forgot to mention skewedness in there. Is that what threw you?
I assumed that was.
We're going to talk about skewedness today. All right, so how about if I do one from each section? So you got the 6 through 9, which is using the histogram. Are y'all okay with that one, using the histogram? Okay. So 10 through 17 ask you to calculate the probability of tossing a coin 20 times and getting the given number of heads. So this is binomial. Do you understand why? Yes. You either get a head or you don't get a head, right? So, I don't know. I guess we'll do 17. Usually the hardest ones come last. 11, yes. 11. 11 says 2 heads, right? And it says that you flipped it 20 times. So I'm going back to that NCK.
Wait, so when you plug that into your calculator, you should put this wrong?
Yeah. Okay. So this would be, there's 20 trials, so it's 20 choose 2. What's the probability of success? What's the probability that you get ahead? 0.5. I know this is not working with me today. This is K. This is 1 minus 0.5, which is 0.5. And this is N minus K. So this is a strictly calculated problem at this point. You should get... I tried to really detail in the video how to put it in your calculator with the parentheses and everything. That helped? Okay. So 0.00018. Okay. You make sure when you do it, one that your pen works, that you put this in parentheses, so it doesn't start dragging you into the next one. Does that make sense on that set? Praise the Lord, the air came on. All right, next set, 18 through 25. What you got? It says 19. All right, so we calculate, thank you, Wills, by the way. We calculate the probability of randomly guessing the given number of correct answers on a 30-question multiple choice test. Each one has choices A, B, C, and D, which gives me my P. What's the probability of correctly randomly choosing the right answer? 0.25 or 1/4. So this one asked me to find it for 2. So I just plug in 30, choose 2, 0.25 to the second, and then that leaves me with 75% to the 28. It's that easy. These are just calculator, and if you use that little method I showed you where you do second enter on the calculator, you can just keep pulling it up, type it one time, keep pulling it up. All right, how about 28 through 31? I heard 33, but before we get to 33, let's do the section before. 28. It says K is less than or equal to 3. This is one of the ones I was talking about where they'll just give you the information. They don't lay out a scenario. They just give you the information and ask you to calculate. So if you think about K is less than or equal to 3, that means K is 0 or 1 or 2 or... or when I'm talking about probability and distributions and things like that, or means to add. So this is just that same formula. Choose 0, 0.3 to the 0, 0.7 to the 7, plus 7, choose 1. Plus 7, choose 2. Does this make sense? It's just a lot, but it's... There wasn't a lot of these because, guys, this should be choose 3. Sorry. 0.74. And then you just plug in the calculator. There weren't a lot of these because once you got it. But I prefer the ones that make you do the entire probability distribution, and then from there you analyze. So you just, once you find them all, then you can add the certain ones, or you can, that's the way your test is laid out. All right. And then you can come through here and plug. Does anybody need me to plug this in the calculator? You good with that? Okay. So for this one, I think you should get about 0.874. Yes or no? Okay.
All right, can you
Anything else? Let's see. A binomial experiment consists of n trials with p probability of binomial. So you should be able to at least do that. You might not can describe it just yet, but you should be able to construct it and go from there. So let's see. N is 3. P is 0.3. So that means my x could be, don't forget 0. Now, when I do this, make sure, the key here is because it does tell me that it's binomial, right? Right? So I know I can use that formula. So I'm just going to use that same formula each time. So 3, choose 0, P is 0.3, and 1 minus would be 0.7 to the third. What do you get? I don't know what you get. 0.3 what? 0.343. Then you'll do the same thing for 1. This is what I was telling you, the ones that I prefer. You'll have things like this on your test, where you'll do the whole distribution, and then from there we'll analyze. 3, choose 1, 0.3 to the first, 0.7 to the second. And what do you get there? Then 2. And you should be getting smaller. Remember, if you've done it correctly, these on the bottom are all going to add to 1. So I'm already at like 0.8, right? What is this, 0.18? So now I'm getting really close to 1 as I add together there. I'm just kind of rounding a little bit. And then for the last 3, choose 3.3 to the third, 0.7 to the 0. What do you get? 0.007? 0.027. And that we've rounded a little bit, but that should add dangerously close to 1. What would be the probability of greater than or equal to 2? What would you do? Add 2 and 3. The probability that x is greater than or equal to 2, we would add these two together, right? All right, other questions? I really thought it was going to be more than that, the way y'all came in talking. It was just a lot. It wasn't that it was so hard. It was just a lot.